All right, on this particular example, we want to look at a comparison test. So we're going to have two functions that we're going to compare, f and g. Let me choose a highlighter here. So here's f right here, here's f right here, and here's f right here. We're going to compare f with g. And what we want to do is we want to notice some different things. And then based off of those different things, what can we make an assumption with about our integral, okay? And so first off, if we have to set it up this way, 0, number one, we've got to be bigger than 0, but f needs to be less than g, okay? It's got to be squeezed in between 0 and g. So if g converges, because f is between 0 and g, it also will converge, okay? So if f is smaller than g, but g approaches a specific value, a specific point, a specific horizontal line, then f will as well. On the flip side of that, if f of x diverges and goes to infinity or doesn't approach anything specifically, since it's smaller than g, g will also diverge, okay? And those can be difficult concepts to think about, but think about a graph. If we were to have a graph of a situation where on the convergent part, if I drew f of x here, and if I drew g of x here, and I told you that f of x was less than g of x, well, my pink line is going to go wherever that purplish line goes, okay? They converge. On the flip side of that, if I take my f of x line, and I say that it's less than g of x now, and it does something like this where it approaches infinity. Well, remember, he's less than g of x. So g of x would also then approach infinity, okay? And so that's kind of how this is working. So here's the question. Does the following integral converge? So they give us 1 to positive infinity of e to the negative x squared dx. Well, let's set this guy up. This would be the limit as b approaches infinity of the integral from 1 to b of e to the negative x squared dx. Okay, looks a little bit on the gross side. So what we're going to do is we're going to let e to the x squared be equal to f of x. So we're going to say f of x equals e to the negative x squared. We want to pick a function that's bigger than that. And so the one that we can pick that's bigger than that we can use for comparison is one that's really similar to that as well. So we could say, hey, what about if we picked e to the negative x? Okay, if we can show that e to the negative x converges, okay, if we can show that this is true, that this statement is true right here, that e to the negative x converges, then since f is smaller, f would have to converge as well. So what we want to do is we want to change our limit and take it from this kind of nasty, gross-looking guy to this one. We're going to look as b approaches infinity, and we're going to look at the integral from 1 to b, but now we're going to look at e to the negative x dx. And if we can show that this guy converges, then we can say that our blue guy converges as well. So here we go. The limit then, when I integrate this, that gets me negative e to the negative x evaluated from 1 to b. And again, that's going to be the limit as b approaches infinity. So stop minus start, negative e to the negative b minus negative e to the negative 1. Okay? Well, keep in mind with these e's, anytime you see a negative on the top, you can always put it on the bottom to get a positive exponent. So this is actually going to be negative 1 over e to the b plus 1 over e to the first. So it would just look like this. Well, notice that when b goes towards infinity, okay, right here, then this part is going to go to 0. The reason is the number on the bottom gets larger, larger, larger. The number on the top never, never moves. And since the number on the bottom gets larger and the number on the top never changes, then we would approach 0. That leaves us with a limit of 1 over e, okay? That's a convergent function, okay? This function converges to 1 over e. So since this guy converges, the f of x part, this one also converges because he's smaller than the one we checked. So we would say that this integral converges to a specific number. And that's all you do for the comparison test. It really is just that easy.